Finally, it's time to move on and build our logic gates using transistors. Now, previously we've already seen, our two types of transistors, namely our NPN and Pnp transistors. And we have also put transistors into circuits, both, on a simulated program, as well as on a breadboard with an actual transistor. So now that we have sort of the basic idea, let's actually go ahead and build our logic gates using our transistors. Well, that's our end goal, right? Basically, now that we know our transistors are tiny units of computation, let's put them together to build even more complex units. You're watching another episode of the Transistors series. Hello and welcome back to Transistors. Today, we're going to be building the NOT gate, our simplest gate that only takes in one input. Let's try and build it in Logisim, both the NPN and the PNP versions, and then we'll see it on a breadboard. So just a very quick reminder of how the NOT gate works. Well, it takes in one input and inverts it, right? False becomes true, true becomes false. Simple as that. We're actually going to start with the PNP version first because this one is more intuitive. Don't forget that everything that has to do with a PNP transistor is inverted. The emitter is connected to high, whereas the collector side is connected to the low. Also, what's coming in at the base is what is inverted, and in fact, that is what makes things so convenient for us. You see, when the base goes low, well, our switch is basically closed, and as a result, our high can flow through. That's why our output is already 1. We of course use a pull down resistor, to go to ground, so that when this switch is actually open, well, our output gets pulled low. So yeah, because of the fact that everything on a PNP transistor is already inverted, we don't really have to do very much. The breadboard itself could be a little bit confusing, so let's take a look at this in a picture form first. I have tried to make things look as close as possible to how things will be laid out on the breadboard itself. I'll be using our power rails at the bottom of the breadboard, and how we're going to get started with our connection is as follows. First, our emitter basically just takes directly from the power source. And on the side of our collector, it goes to ground through a pull-down resistor. The switching at the base is fairly simple as well. We simply have a little push button, right, that takes directly from our high source. It goes through a resistor to limit the amount of current that actually goes to our base. And yeah, we just connect that in directly. So essentially, this is our entire setup, very simple for a PNP transistor. Let's see it on the breadboard. Alright, our first breadboard shot of the day. Now, as per the schematic, I have power and ground coming in over, well, my actual rails. The switch is here, right, and that will control the LED. Since this is supposed to be a NOT gate, it switches off when I press down on the button. Here is our transistor. It is a Pnp transistor. In terms of its connection, the emitter, which in this case is our input, is just connected directly to power along the lower rail here. The base is fed by the switch, which goes through a resistor so as to not, well, flood our transistor with too much current. And on our output side, that would be the collector, which goes to the LED, through a resistor, back to ground. It's as simple as that. Our switch of course gives us 0 or low by default, which is why our LED is lit, but the moment I press down on the button, our LED goes off. And that is simply because, well, the incoming power has now been cut off. So yeah, this one is fairly intuitive. As we move on to the Npn Transistor version, you'll find that is a little bit more complex. Now, if you remember previously when we looked at our Logisim simulations, I told you that inside a transistor, that little arrow basically tells you, well, which is the input and which is the output. We have also seen a case where this could be a little bit confusing, and this is another one of such cases. So for simplicity's sake, I want you to actually ignore that little arrow there. Right? Don't think too much about it. Instead, focus on the fact that this side is the collector, we are connecting it to the high side, which is correct, and the emitter, which goes down to ground. Now here's the deal. We're doing something slightly different here. We are actually taking our output from the upper half instead of the lower half. That is, output comes first before switch. The reason will become more obvious when you realize that our pull resistor is actually pulling up, not down. As a result, what happens is when the base goes high, well, our output is connected more directly to ground, and as a result, it goes low. When our base goes back to low, the switch is now open. Therefore, the only thing your output can touch is your high state through the pull-up resistor. So yeah, pretty interesting inversion of how we do things. And again, this is why, well, this little arrow here is kind of misleading because current is flowing in the opposite direction. Again, don't worry too much about this, right? Just stick to our basic understanding of transistors, which is, well, collector needs to go to high, emitter needs to go to low. So for our NPN setup, it is still fairly basic even though we have to do one or two more things. Now, the emitter goes straight to ground. Nothing too out of the ordinary there. Our connection for the base is also exactly the same as we've seen before. The more complex part is how the LED actually fits into the entire picture. Now, firstly, what we have is our LED. This LED is basically connected directly to ground and to our high through a pull-up resistor. Now, if we were to actually ignore this pin over here, right, and just sort of concentrate on what's happening on this particular leg, if we leave things as it is, the LED has a connection to our high source. And as a result, it's high here, it's low here, the LED lights up. Now, we're going to make our last connection to the transistor here. So what's happening here is when this switch is open, what that means is this switch is also open. There is no direct connection between your collector and your emitter, and as a result, that's really no different from not having this connection, right? Your LED is connected via the pull-up to our high state, causing it to light up. When you actually close the switch, collector and emitter are now connected, and what that means is this pin of the LED is more directly connected to ground through the transistor than to our high state because that's going through a pull-up resistor. So as a result, our LED switches off. Let's see that in action. So in accordance to this schematic we have seen, here is the NPN version of the setup. Right, we have our switch here. It is feeding the base of the transistor through a resistor here. We have power coming in via this wire. It goes through a resistor, which then feeds both the transistor as well as the LED, which is also going back to ground. Finally, the emitter, of course, just goes straight back to ground. When I press on the switch, well, the base goes high, and as a result, the LED switches off. Because now, the LED is basically directly connected to ground through our emitter pin. The collector pin is still high, which means, of course, that is also directly connected to ground, but through a resistor here. So that is how we build a NOT gate using an NPN transistor. And there you go, that was the NOT gate, the simplest gate of all because it just takes in one input. As the series progresses, we will be building more and more complex components, and hopefully where I want to end up is we can build something that has a little bit of memory with transistors on our breadboard. Well, that's all there is for this particular episode. Thank you very much for watching, and until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.